Welcome to Ask and Learn.
All right, here we have a nice modeling question. We have a model for the depth of water at Hopewell Cape. The depth you can see here is this kind of trig expression. The depth is in meters and the time is in hours. And we want to find the rate of change at different times. So let's first go ahead and find the rate of change, which is the derivative, and then we'll plug in our values. So, whoops. Okay, so we're finding the derivative. The derivative of 7 is 0, so 0 plus 5 goes along for the ride. The derivative of cosine is minus sine. We have a big chain rule. So at first with chain rule, when you have a composite, you take the derivative of the outer function and you leave the entire argument the same. So let's go do that. Okay, then we multiply by the derivative of the inside argument. And the derivative of the inside argument is 0.503 coming along for the ride. And the derivative of t minus 6.75 is just 1 minus 0 or 1. Okay, so let's clean this up. D prime of t then is going to be equal to minus 5 times, oops, actually I need to multiply. Let's get this all cleaned up. We have a minus 5 and a 0.503. So let's multiply that out. That will give us minus 2.215 sine of 0.503 t minus 6.75. Okay, so that is our rate of change of depth in meters with time. And time, by the way, starts at t is 0 is midnight. T is 0 hours is midnight. Okay, and we'll need that when we find the specific time. So just a reminder, we definitely need that. Okay, so really all we have left to do is plug in for t the different times they gave us. So let's go ahead, and I'm going to set this up. I'm going to show you the result. I'm not going to rewrite it each time because it will be very repetitive. Our times of interest are 3 a.m., 6 a.m., 9 a.m., and noon. Now notice 3 a.m., that we're doing it from midnight, so that's 3 hours after midnight. So that is when t is 3 hours. And 6 will then be t equals 6 hours and so on. So they made it nice. We don't have to think too hard if it's after midnight. And t equals 12 hours. Okay, so the next step, really all we have to do is plug in each of these values in for our t. So in our calculator, we go ahead and put in the whole expression, and the only difference between A, B, C, and D is we're going to plug in either 3, 6, 9, or 12. So let me give you the values that you get when you plug it in. When you plug in 3, you're going to get that the rate of depth, rate of change of depth with time is 2.39, and that's in meters per hour. Let's see, at 6 a.m., let's get that value. And I'm doing this in radian mode. So make sure when you use your calculator, you are using radian mode. Otherwise, you won't get the right values. So reminder, radian mode. Okay, so then let's find the rate of change of depth at 6 a.m. That's plugging 6. Now we're going to plug 6 in for t. And when we do that and plug it into our calculator, we will get 0.926 meters per hour. Let's do 9 a.m. So we're going to plug in 9 for t. So d prime of t, our depth rate of change, is negative 2.276 meters per hour. And finally, let's do one more color. Let's do, how about brown? Okay, so at noon then, we're just plugging in 12 for t. Then our rate of change is equal to minus 1.208 meters per hour. So if we want to know how quickly the depth changes, depending on the time in the morning, you can do it this way. So pretty cool. I really like these modeling problems. All right, have a wonderful day. See you next time.